The Birch-Swinnerton-Dyer conjecture? Yeah. That says you have some cubic equation in two variables, and then you do some hard calculation, you get a number, and you do some completely different calculation, and you get another number. And Birch and Swinnerton-Dyer just observed that those two numbers are always the same in all the examples they tried. So it's just, it's two numbers being equal. But you do lots of hard work to work out each of these numbers. And it's not just hard work, it's very hard work of a very different nature. You do a lot of algebra and work out some number, and then you do a lot of analysis and work out some other number. And the numbers are the same. And that's really funny, because algebra and analysis are really different, right? Because analysis is the study of the real numbers, and everything is continuous and moves, in some fluid manner. And algebra is the study of the discrete, so it's the study of, the counting numbers and things like that. Things which can't move smoothly. You kind of jump, you're 3 and you want to get a bit bigger, you've got to go to 4. That's quite a leap, really. So algebra analysis don't really fit in the same box, and yet sometimes they give the same answer. But the Langlands philosophy, that's like Birch-Swinnerton-Dyer on crack, isn't it? That really is. There's a lot of analysis involved in that, and that's why it took me so long to actually learn what the question was. So there's calculations in harmonic analysis, giving you random things that Langland suddenly noticed were that you would do calculations involving Galois groups, very concrete algebraic objects that were utterly unrelated to harmonic analysis. And they would give you the same numbers as well. So here it's not just a number equals a number. Here it's a function equals a function, or a collection of numbers equals a collection of numbers. But Langland's made some very insightful remarks about these strings of numbers coming from two completely different... So the Birch-Swinnerton-Dyer, so you take a cubic equation and then you do some analysis with it and get a number, do some algebra with it and get a number, and these numbers are the same. But this is very different, really, because here you're taking a whole area and it's belching out sequences of numbers, and you take a completely different area that's belching out sequences of numbers. And then if you're Langlands, you notice that sometimes these numbers are kind of exactly the same. So he made some conjectures that basically said that two areas of mathematics, which is two different ways of thinking about the same thing,